Here's a typical equation that we have to balance. A chemical equation is like a before and after picture, where the arrow in the middle represents the change that's taking place. On this side, we call these the reactants. This is what we started with. Here, a change takes place chemically. And on this side, we have what's left over, what we call the products. The conservation of matter says that I have to have the same amount of matter when I finish the reaction as when I started the reaction. So our goal is to get the same number of atoms for each element on both sides of the arrow. To do this, we need some rules. Our first rule says that we cannot change the formulas. Magnesium oxide, earlier in the year, we figured out how to come up with its formula based on the cancellation of charges. And that's the way it is. We can't change it. Diatomic oxygen always has 2 atoms bound up in its molecule when it's in its free elemental state. So what can we do? Well, we can change coefficients. The coefficients are numbers that are going to appear here in front of the substances. Those numbers can only be written in front of the entire substance. We can't, for instance, put anything in between any of these compounds. It has to be written where I've drawn in these purple lines. Finally is our overall rule. We have to have the same number of atoms for each element on both sides of this arrow. Now this is a matter of organization. So we need to learn how to organize this. For people who are just starting at balancing, sometimes they find it handy to create some type of a ledger sheet, some way of recording the number of atoms for each element on both sides of the arrow. So I've drawn in a purple line, and this is going to be what separates our reactants from our products. And I'm going to write in each of the 2 compounds that are each of the 2 elements that are in our equation. So I have magnesium and oxygen on both sides of the equation. And then it's just a matter of counting. For magnesium, I have 1 atom. And oxygen here, magnesium on this side, I have 1 atom as well. Oxygen on this side, I have 2 atoms, so I'll put that in for oxygen. And on this side, I have 1 oxygen. Now our magnesiums are looking pretty good with 1 apiece, but our oxygens, we can see I have 2 on this side and only 1 on that side. This is what we would say unbalanced. And there's a deficiency in the number of oxygens over on this side. So here's a tip. This is what balancing is all about. We want to find the one that is smaller. In this case, over here, the oxygen is smaller. This compound right here, we need to increase the coefficient by 1. And we should only change it by 1 at a time when we're first beginning. So it was a 1, now I'm going to make it a 2. In my ledger sheet down here, I need to make that change. So now instead of 1 oxygen here, now I have 2. So I'll change that down here to 2. Now my oxygens are looking pretty good. But I noticed when I made this change that this 2 not only increases the number of these oxygens, but it also increases the number of magnesiums. So I need to make that change on my ledger sheet now. Now my magnesiums aren't looking so good because I have 2 on this side, 1 on that side. So this is a common problem, and we want to do the same steps again. We want to come over here, find the one that's smaller. Here's the magnesium. I need to increase its coefficient, so I'm going to change it by 1, increase it to 2. And now I'll change that in my ledger sheet. And when I look things over, I have 2 magnesiums, 2 oxygens. Things are looking good. We're done.